Good evening. It's sunset, or actually about 15 minutes after sunset. And I thought I'd give just a tour of the sky and some of the things we're going to talk about as far as positions on the sky. The first thing is, there's the zenith directly overhead. And I don't see any stars yet, but trust me, there'll be some stars coming out. And you also need to know the directions north, south, east, and west. The direction north happens to be in that direction right there. I know that because, hey, these are the athletic fields at Cranbrook. I know what the directions north, south, east, and west are. And if I waited long enough, about 42 degrees up in the sky whoosh, is the star we call Polaris. So the altitude of Polaris, which is at the north celestial pole, is equal to our latitude here. And that's true for any observer here on Earth. So if you live at the equator, for example, your latitude is 0. The north celestial pole, Polaris, would have an altitude of 0. It'd be right on the horizon, if you could see it. So there's the north celestial pole. There must be a south celestial pole, but I can't see it because it's below the horizon. So the whole sky seems to turn around that pole. So if there's a north and a south pole, there's got to be an equator halfway through the poles. And the equator is, in fact, halfway through the north and south celestial pole. It goes across the sky. Right now, there you go, there's an airplane going right through my sky. So the celestial equator, since it's halfway between the north and the south, has to be through the east and the west points as well. So in my mind, I can see a celestial equator up there. The other thing that you need to know about how the sky works is that I need to find things in the sky. 2 measurements. You only need 2 angular measurements, and those 2 angular measurements are going to be altitude. That's pretty obvious. I see, oh, there's the moon out there. I have a handy way, literally, to measure the altitude of things. I just take my fist, which is about 10 degrees, and I sort of guess where the horizon is. I'm saying right now, 1, 2, 3, yeah, maybe 3.5 fists. That makes the altitude of the moon right now to be 35 degrees, 3.5 fists, assuming my fist is about 10 degrees. The other direction that you need is not up and down, altitude, but around the horizon, which is called azimuth. And azimuth is measured starting from the north around the horizon. Hey, east is 90, south is 180, west is 270, and then again to 0 or 360 in north again. So I'm going to take a guess as to what the altitude of the moon, or the azimuth of the moon right now is. And these are all just approximations. You can measure them a little bit more carefully. So the azimuth is, starting at north, there's 90 degrees in the east, and it looks like, I'm guessing, about 20 degrees short of south. So I'm going to say the altitude, or the azimuth, of the moon right now is 160 degrees. So what do we have? We have an altitude of 35 degrees and an azimuth of 160 degrees. Those 2 measurements are called the horizon system. Obviously, it's attached to the horizon. And if you think about it, the horizon system is personal for every observer here on Earth, because everybody's got their own north celestial pole in the sky, and it's in different locations. Everybody's got their own celestial equator. If you're at different latitudes, if you're at different longitudes, the sky looks different. So the positions of objects up in the sky, as far as their altitudes and azimuths, is unique for each observer. Of course, now we get to the other coordinate system, right ascension and declination, which is the equatorial coordinate system. That one moves along with the sky. Looks like it's going to be a great night. Where's my telescope when I need it?